exponents in the first week. If you have my email over the weekend, there is a workshop that we're offering. So why are we not? I guess. The worst thing that happened to education is technology. You give me negative points, like, oh, shoot. I can do better. Minus nothing. Come on. Nothing. Hold up. So I sent this flyer. It's posted in the room. It's over there. It's over there. But yesterday was exploring exponents. We did exponent rules. I mean, it's quick. It's only now, but every Tuesday from 1 o'clock to 2 o'clock, there's a workshop in the Learning Center, the STEM Center, AB 2229. Next week is going to be factoring fundamentals, learn by doing. You're going to have to factor in this class. Don't always have time to teach factoring. I try to, but if factoring is weak, you're not going to get by without knowing how to factor. So next Tuesday, 1 o'clock to 2 o'clock, factoring. So Tuesday after that, simplified algebra, solving linear equations. That's what this is, solving linear equations, solving inequalities. March 11th, preparing for exam success. Graphing, my next one is going to be logarithms, which is important because right after that, somewhere down here, we're doing logarithms. Now, the unfortunate thing is, this logarithm little hour thing that I'm giving is before you even see a logarithm. We're trying to find something to help build your foundation. For all the students, this is for everybody. Okay, this goes out to the entire Madera Community College community, and it's different professors every week. Maybe you find a new professor you'd rather have. Okay, Handarian's hilarious. Okay, I tell you, Cortez Houghton, force to be reckoned with. She's amazing. And so is Ms. Beeler. Just watching them run the show, it's amazing. I'm in awe of those two. How much they take off, how much they do so can't there and just blow me away. So like I said, next week, factoring. All right. The 10 rules of exponents. That's what you had to follow. You had your quiz preps to help you. Okay. You were right next to each other. I can hear you all the way up here, which means the people right next to you, it's like trumpets in their ears. So please, if you're whispering, we shouldn't hear you. But I'm trying to give you some perspective. If you're, what do I need to do to get better? What do I need to do to pass the class? All these questions that I hear all the time. It's hard to learn, hard to intake information when you're speaking, it doesn't allow you to hear anything. Sound waves cancel each other out. So when you produce sound waves, it's going to cancel out the sound waves you're trying to have come in. They destroy each other. which is why if you have an argument with somebody and you're both trying to talk at the same time, nobody's listening. Okay, that's where people get upset with each other. At least that's what my wife did. But these rules of exponents aren't going to go away. This is it. This is your roadmap. And that's good news. What I told my little, hour-long TED talk yesterday was, if you've ever played a game with someone, but they tell you, well, where I come from, these are the rules we use. We play Monopoly this way. We can get out of jail if we roll a 6. We don't have to pay the money. We don't have to get out of jail free card. We can do it any other way. We don't have to do it what the game said. We figured out a better way to do it. If nobody's playing by the same rules, or everybody comes up with their own rules, nobody wants to play. Math has rules, so we all get to the same answer. Okay, gotta follow the rule. So here on the first one, simplify what's always parentheses, exponents, multiply, divide in order from left to right, and then add or subtract from left to right. Simplify what's in parentheses. There's nothing you can do in the parentheses, but you now have exponents. You have this parentheses to that power, this parentheses to that power. This is rule number 2, power to a power. So, sorry, actually it's rule number 3. Each factor gets the power, and then you have power to a power. The next step should have been this. You have 24 out here still. Inside this parentheses, x to the 4th to the 3rd, power to a power, 4 times 3, that's x to the 12th. Y to the 5th to the 3rd, power to a power, that's y to the 15th. XY to the 2nd, so they're both 1, so 1 times 2, that's an x to the 2nd, that's a y to the 2nd. And then you have times 3x. My first question is, are there any negative exponents in that problem? No. The only way you'd have something flipped down to the denominator is if you had a negative exponent. On this question, I had many, maybe a handful, 5, maybe 6. They flipped them down. There's no negative exponents. Everything's going to stay in the numerator. Nobody flips. But you're just kind of confusing. So I know I'm supposed to flip at some point, but you're not exactly sure when. So you kind of flip randomly. If you're doing something randomly, you're not doing math. Because we don't do anything randomly when we're trying to do the rule. Okay? So now we're going to multiply, and when we multiply, we add the exponents. First of all, I got to see that you have 24 times a 3. If you laid all of this out, you have a 24, and you have an x squared. You have another x squared. Sorry, x is 12. And that's another thing. Have I mentioned something about writing neatly?
Yeah.
At least I know I've said it. So you guys, I gotta read what you want. You give credit for. Seriously. I mean, I'm not trying to pick or anything, but if you fill out a job application and they can't read your phone number, you don't get the job. So if I can't read what you wrote, some of you aren't reading what you wrote. So you don't see the negative that you just had right there. So you didn't flip it. Or like right here, that 12, the 1 almost disappears. So all you see is the 2. So you now believe it was a 2, or over here you had it right, but over here when you wrote it, it's wrong. Take the time. Take the time to do it as neatly as you can, and you actually will have better success. So you have x squared, x to the 12 times an x squared times an x squared, and then you have an x to the first. Those are all my x's. They don't live in Texas, they're just right here. I have y's, a y to the 15th, and a y to the second. And those are the only y's. So I should have 1, 2, 3 x's, 1, 2, 3 of them. And I have just 2 y's, those 2 y's, a y to the 15th, y squared. And then don't forget this 3. Some people forgot the 3. The 24 times the 3. 24 times 3 is 72. Then you add the exponents when you multiply. 12 plus 2 is 14. And what's this exponent right here? That's a 1. So 12 plus 2 is 14. 14 plus 1, that's a 15. X to the 15. And y to the 15 plus 2, that's a 17. If you clean up what you're doing, you might see things a little nicer. All you had to do was raise everything to the power on the inside, and then you have a 24 and a 3, so 24 times the 3 gives you the 72. And you didn't even have to do this part. You could have gone right to here. Because I can see the 24 times the 3, 72, x to the 12 times x squared times x, 12 plus 2 is 14, plus 1, x to the 15th, y to the 15th times y to the second, 15 plus 2 is 17. Okay? Now we have negative exponents. It's still inside parentheses to the power, inside parentheses to the power. So I have to simplify what's inside if I can, and then raise that to the power before I can multiply anything together. Okay? I'm not going to flip anything until I raise this to the power, because maybe I'll take care of some of these extra negatives. Power to a power, we multiply, just like we did up there. So this 8 times x to the negative 3 to the negative 2. Up here, we multiply. We do the same thing here. It's x to the negative 3 times negative 2. That's a positive 6. Y to the 4 times negative 2. That's a negative 8. Power to a power. And then here, don't forget the 5 is in the parentheses. 5 to the second. And if you want to go ahead and put 25, you can, but it's 5 to the second. X to the negative 4 squared. Negative 4 times 2 is x to the negative 8. Y to the third squared. 3 times 2, that's y to the positive 6. So I took care of the parentheses to the power. Each factor got the power. I still have this 8. Now in here, you can flip this. This would be an x to the 6 in the numerator. Y to the negative 8 would flip down, become a y to the positive 8. And here's what I saw. Because you saw one negative exponent, the y to the negative 8, you flip both. Some people flip both. You only flip the one that has the negative power, and when it flips, it becomes a positive power. So that one flips down. Here, 5 squared in the numerator, that's a 25. 25 times 25, that one. X to the negative 8 is going to flip down, become an x to the positive 8. Y to the 6 is going to stay put. Y to the 6 stays up here. Positive exponents stay put, negative exponents reciprocal. Flip. Now, I'm just gonna, I can reduce right now, but I'm just gonna clean up what I got. Clean it up. What we have is we have the 8 times the 25 in the numerator. And then alphabetically, we have the x to the 6th and the y to the 6th in the numerator. In the denominator, we alphabetically, we have an x to the 8th and a y to the 8th. Eight times 25 is 200. That's in the numerator. When we divide, we have the same base. We subtract the exponent. We basically look at which one has a bigger power. The denominator does. How much bigger is 8 versus 6? How many more? 2. So this x to the 6th is going to reduce and go into x to the 8th, leaving in x squared. So x to the 6th goes into x to the 6th once, and x to the 6th goes into x to the 8th, leaving x to the 2nd down below. Same thing with y to the 6th goes into y to the 6th once, and then 8 minus 6 is going to leave in y squared down below. So 200 over x squared y squared. So we have to simplify that. First thing I'm going to do is I'm just going to reorganize. I'm not going to try to clean up, do everything all, one step. I'm just going to reorganize. So I'm going to rewrite this as 8 and times the 25. And then I have a z to the 3rd times the z to the 8. And then down here, I have a 12. But I can do this one thing. I know this is z to the negative 6 because it's a negative exponent. It's going to flip up and it's going to join these two and become a z to the positive 6 up there. So the direction said, simplify, leave your final answer, positive exponents on. Okay. So now I just have to simplify the 8 times 25 over 12. 25 and 12 have no common factors, but the 8 and the 12 do. So 25 is not going to simplify, but 8 and 12 will. So this will be 8 is 4 times 2, and 12 is 4 times 3. So the 4 reduces. I have 2 times 25. So in the numerator, I have 50. In the denominator, I have a 3. Okay. If you want, you could multiply 8 times 25 is 200.
But you still have 200 over 12, so now you gotta simplify that. That's equal to 4 times 50 over 4 times 3. 50 over 3.
Okay? You always have to reduce your fraction. And then you just gotta multiply the z's, and when you multiply, you add the exponent.
3 plus 8 is 11. 11 plus 6 is 17. Z to the 17.
Fifty times z to the 17, all over there. Simplify things, because if I need to use whatever that is somewhere else, I want the simplest representation for it. And this is just practice, so we can do whatever comes our way. And learn how to use the rules of exponent. Then the fourth kind was something like this. So parentheses, 28 times x to a negative 7 over a 35 with an x to a negative 3, the whole thing to a third. Order of operations. The first letter, P, parentheses. Simplify what's in the parentheses first before you raise it to the next letter, which is exponent, before I raise it to the third. And a lot of you did that, but then you dropped the parentheses. It's like it was never there. You did the simplification, you remember this was 3, but you didn't raise everything to the third. You raised the variable to the third, but you didn't raise the fraction left to the third. So when you do the steps, rewrite everything as it's supposed to be until you take care of all the pieces. This fraction. The common factor for 28 and 35 is 7. This is 7 times 4. This is 7 times 5. So when I reduce this, I get 4 over 5. Four over 5. And then I don't want to deal with negative exponents, so I'm going to flip them. X to the 7th is going to go down here. X to the 3rd is going to go up here. And everything is still to the 3rd power. I see, I'm not done with the problem yet. I'm not done with the inside. Parentheses still. One last thing I can do. When we divide, subtract the exponents, which one has a bigger power, numerator or denominator? Denominator has a bigger power, 7 versus 3. So when we divide, we subtract the powers. Since the denominator has a bigger power, x is going to end up in the denominator. 7 minus 3, we're going to leave an x to the 4th. So we're left with, in the parentheses though, 4 over 5x to the 4th. Everything to the 3rd. It's still I have to raise everything to the 3rd. So I'm going to now, rule number 4 on your top 10 rules of exponents, we have a fraction to a power, the numerator and denominator both get the power. So this 4 gets raised to the 3rd, and then this is a product, 5x to the 4th, that whole thing gets cubed. And this is like doing
all of it, one step at a time. 4 to the third is 64. Now I gotta raise the product of the power, so 5 gets cubed. And then x to the fourth gets cubed. So I get 64. 5 to the third is 125. Power to a power, you multiply 4 times 3 is x to the 12th down.
Now, everything that can be done has been done. Now,
You could have gone from here right to there.
you gotta practice. Here's what I noticed when you were taking this quiz. Yes, it's open, no. That is not a good thing. I don't mind that it's open note. I'm giving you that option. But I'm also giving you the quiz preps, so you actually have done them before. Now you show up and you just have it as not the crutch, but a guide if you feel stuck. But what I'm seeing is, okay, I'm going through notes, I'm like over here, spending all the time going through everything, looking for an answer, instead of just doing it. All the problems on the quiz preps, there they are. Were there any surprises? Okay. No surprises.
On the bonus point,
Mhm.
with the 2 6 eggs and then the over 2.
2 to the second x.
So 2 to the 6x over 2 to the 2x. What's the rule when we divide? What do we do with the exponent? So that's 2 to the 6x minus 2x, so we get 2 to the 4x. And if you got that, I was good. But this is 2 to the 4. When you have power to a power, you multiply. Since this is multiplication, it's 2 to the 4th to the x, and 2 to the 4th is 16 to the x.
Everybody had a version of that. Okay. Solving. In a nutshell, when we solve it, we want to undo what's being done. We want to unravel what's being done to whatever we're looking for. And we want to be careful about it. Again, all rules. It's like growing up, there were so many of us, there was 6 kids. We just handed out Christmas presents and everybody just opened theirs at the same time. Nobody knew what anybody got because we were all like, it was just us. My world, their world, nobody cared. In my family, we all take turns, starting with the youngest to the oldest, and everybody watches everybody open their gifts, so you know what everybody got. Okay. If we did that way back when, because I used to watch my nieces, they would unwrap the wrapping paper so they didn't tear anything. It would take them 5 minutes to unwrap one gift. They were incredibly careful. You kind of treat equations a little bit like that, really careful. Because one wrong move, you're not going to get the right answer. And that's all you're doing. You're going to unravel that equation so you have x by itself. Operations that you're dealing with: addition, subtraction, multiplication, division. We undo addition with subtraction. We undo subtraction with addition. Opposite operation. We undo division with multiplication. We undo multiplication with division. So we just want to undo what's being done to the x. That is the key to solving anything. Undo what's being done. Okay.
So that first one, you might be able to look at it and think without even doing, any work. Oh yeah, the answer is going to be negative, or the answer is going to be -20. Maybe you can see it, maybe you don't see it. Coming up with -20 is not an easy thing to just look at and see. But the deal is, you're not supposed to stare at it and come up with an answer. Remember, no work, no credit. Show me the work. So on number one, x plus 8 equals -12. I have x plus 8. I want x by itself. I have to undo addition. So to undo addition, I subtract 8 from both sides. On this side, 8 minus 8 is 0. So you don't have to show this part, but I end up with x plus 0. -12 minus 8 is -20. X plus 0 is just x. So we get x equals -20. If I plug in -20, it makes the equation work. Undo what's being done. We're adding 8 to x. I want to undo the plus 8. Subtract. Okay. On the second one, we have a couple of things going on. We have 3x minus 5 equals 19. So the last thing you do is undoing multiplication or division. It's kind of like you're doing the order of operations a little bit backwards. You're going to undo anything added or subtracted. And then you're going to undo multiplication or division. What you have to do is you want to separate, or let's put it this way. I guess separate in this way. Separate variable terms from the constants. In other words, you want to gather all variables on one side, and it doesn't matter which side, and then constants on the other. The goal is to get x by itself. So I want to separate x from all the other constants. I want just x by itself. So I'm going to undo the -5 first. I have to add 5 to both sides. And I get 3x equals 24. So if I separate the variable terms from the constants, I should have a variable term equal to a number. And now I'm going to have either multiplication or division with my variable. So the last thing you have to do is just undo multiplication or division. So we separate the variable and the constants, and then you're going to undo multiplication or division. X is being multiplied by 3, so all you have to do is divide by 3. X equals 8. Now, just so I am perfectly clear, three x equals 24. This is not dividing both sides by 8. I've been seeing this for the last 3 or 4 years. So there is some elementary school teacher out there, high school teacher out there that is showing this crap. Because it's not coming aside, one student's doing it.
I'm seeing it from multiple students. And that is not mathematics. I don't know who's out there doing it, because you're not dividing both sides by 8. You're not even dividing one side by 8. Because if you do this, oh yeah, 3 goes in, sorry, go ahead. If I do that, then what's gonna go into the 24? Because you already canceled out 3. You didn't divide each side. You do that on a test, I'm taking off 1. I'm serious. Because if you're gonna do math, you gotta treat math like, you don't want to go out there in the world and embarrass yourself. That's embarrassing. Whoever taught that should be embarrassed. Let me know who's there. Or whatever. I got 4 other math professors around here. We're gonna talk. And we have a credential for everybody. And then here come the fractions. Those fractions. Okay. It's good, honestly, because I was looking for somebody who might try to raise their hand. I was just going to call them a liar. When you're solving an equation, you don't have to deal with the fractions. Little something called multiplication. You can undo fractions if you multiply every term by the least common denominator. A fraction is division. This one is being divided by 3. This one's being divided by 5. That one's being divided by 4. So if I multiply, but you have to multiply by every term by the same number. If I don't do the same number, it's not the same equation. I have to multiply each one by the same number that will undo those denominators. I need the least common denominator, the smallest number that 3, 5, and 4 all go into evenly. So what is the smallest number that 3, 5, and 4 can divide into evenly, least common denominator? Pretty well go into 20. Here's how you do it. First of all, you're never going to figure out 3, 5, and 4 all, what? 5 not going to go into 12. 16. It's going to be 60. You're never going to figure out all 3 of them all at once. Pick 2. 3 and 5. The first number 3 and 5 going into is 15. Now you got to think about 15 and the 4. Well, 15 times 1, 15. 4 doesn't go into 15 times 2, 30. 4 doesn't go into 30. 15 times 3 is 45. 4 doesn't go into 45. 15 times 4 is 60, and 4 goes into 60. So the first number that all 3 go into is 60. Or you can pick 5 and 4. 5 and 4 is 20. 3 can't go into 20. 2 times 20, 40. 3 doesn't go into 40. 3 times 20 is 60. 3 goes into 60. You pick 2 numbers, figure out their common denominator, and then you look at the other number. And but you need the least common denominator. So I'm going to multiply every one of these by a 60. You get, it's like Oprah's show. Last Oprah, you get a 60, you get a 60, and you get a 60. If I do it to all of the terms, it's going to be the same equation. The purpose is to undo the fractions, to reduce the fractions so we don't have fractions. 3 goes into 60 how many times? So I have 20 times 4x, that's 80x. 3 goes into that 60, 20 times. I'm left with 20 times 4x, that's 80x. Minus 5 goes into 60, 12 times.
12 times 8 is 96. Equals. 4 goes into 60 15 times. 15 times 3 is 45.
No more fractions. Now I'm just gonna solve this problem. The answer to this question is the same as the answer to the original problem.
I want to separate the variable from the constants. I'm leaving this 80x over here. I'm going to add 96 to both sides. So I have 80x equal to, you know, 1, okay, 1, we have 14, 141. And then what do I do next? Divide by? Divide both sides by 80. They each get their own 80. So x is equal, reduce this to lowest terms. The only thing going into 80 is a 2, a 5, that's it. Because this is 8 times 10, which is a 2 times a 2 times a 2 times a 2 times 5. 5 doesn't go into 141 and 2 does not go into 141. So there's no common factor. This is lowest terms. Do not write it as a mixed number. Leave it. Don't write it as a decimal. Only decimals if the directions say so. Can you stop right there? Now, I'm gonna put a few of these back up to begin at 10 o'clock. And I'll put up number 4 and 5 back up at 10 o'clock. Okay? I'm on back at 10.